I'm Kim Walton, and I live in the BRRRR Valley, which is somewhere northwest of Calgary in the foothills. And I've been in this business of building sustainable buildings since I was 12. You can see I'm preaching the gospel of integrated greenhouses for buildings in the photograph, and that's a whole other topic, and I wouldn't recommend that you do that. So I don't have to do this because already you've heard from Jim and Donald about what is a passive house, but it's a concept that was started in Canada. And what I'm going to talk to you about today is about certifying through two different organizations. So one is PHI, or the Passive House Institute, and the other is PHIUS, which is the Passive House Institute US. The principles, Donald had already talked about this, just a lot of insulation and air tightness and thermal bridge-free construction and really good windows and a ventilation system. Those are the 5 components, and what we do with certification is ensure that those are done well and appropriately. The reasons that you might certify, because it's expensive, besides doing all of the work that you need to do for getting the building to a certified standard, certification also is an additional cost. There's fees for the people who are working on the project that will help to bring all the information to the certifiers, and then there's all the fees for certifying. But the reason that you would certify is, number one, that you're ensured that you have a comfortable, healthy, and robust building, which is the whole purpose of doing passive house. And the cost of heating and cooling is minimized, and the lifetime maintenance costs are minimized. Jim told us all about that. And certification is proof of a superior product. Somebody that I know recently was making a decision about certification, and they were told by their real estate agent that they should certify. And the reason for that is because comparing a building that looks the same as another building doesn't get you the value of the building, but certification does ensure that the building is performing the way it's supposed to. Okay, so this is what does it take to certify to a PH standard. So with PHI, which is a Passive House Institute, we've seen this slide already, this one. We have certain goals to meet, and they're hard and fast. So in order to do a classic certification, it's 15 kilowatt hours per meter squared, or a heating load of 10 watts per meter. And the cooling demand needs to be reasonable, and the primary energy demand needs to be under 120. And these, and the air tightness at 0.6. That is really, these are all really a big deal. And in order to get to the certification level. The definition of a heating demand is the energy used annually based on the passive house method for calculating floor area and volume, which is not the same way that you would normally calculate floor area and volume. And the heating load is a definition of the heating load for a passive house is a maximum heating power, which is necessary to keep the internal temperature at 20 degrees Celsius and for 24/7 during the winter. The primary heating demand is the total energy to be used for all the domestic applications. So that's all the base loads, all of the heating, as well as the heating, hot water, and the building air tightness needs to be 0.6. And that's 0.6 ACH. So getting to 0.6 seems like it's kind of crazy. I think the standard for building code in Canada is it's 2.5 is about what we're looking at for a very good building, and probably most older buildings are at 4 or 5. So 0.6 is a very airtight building, and so in order to, when you're doing that, you do have to consider that ventilation. It's an important aspect. But when you're doing an airtight building, getting to 0.6 is the first hurdle, but many people do get them that practice this, get buildings to 0.1, 0.3 pretty easily. We use the Passive House Planning Package, that's a PHPP, for determining whether a building will meet the criteria for certification. And this is it's really a big spreadsheet, and it's many, many pages that are intermingled with each other that help to determine whether the building is meeting the criteria. This page that we're looking at is the verification page. So what happens is that you use the software and you move parts around, you play with the different aspects of the building in order to see whether you're making the grade on everything just gets calculated on this front page. We use another software that's tied into the PHPP called Design PH that we can use to feed into the PHPP. And it's a plugin using SketchUp. This is a really good and fast way to figure out whether a building is close to being certifiable. We use this sometimes for a building often that isn't being certified, but just so that we know if we're getting close to a certification level. So the process for certification, the very first thing you need to do is find a certifier, certifier and also somebody who is going to help you with designing your building to certified level. In the design stage review, it's important that those people are involved with all the decision making, all of the aspects of the design. Otherwise, it's very difficult to get to a certification level. Then after construction, when the project's fully built and commissioned, the evidence for all of the work, and that's usually in photographs and documentation, is reviewed by PHI in order to get the project certified. So I'm going to talk about a couple of three projects that I have been the certifier, not the certifier, the certification expert or have worked on and that have become certified. So this is in the town of Valemount, which is west of Jasper. It's in BC, and it's in Zone 7A. It has 53, 57 heating degree days. And just incidentally, I just thought I'd check this out just so that you know, Winnipeg is about 6,000 heating degree days, so Winnipeg's colder. But this is in the mountains. It does have a lot of shading because of mountains and this location. The architect for this project was Vincent Sue, and the builder was Olofsson, Eric Olofsson Construction. What we did with this building, or what the plan was to use the Larson truss, and I'm so glad that we had so many nice photos of Larson trusses. So it's a Larson truss approach, and the building was surrounded with insulation. The air tightness ended up being 0.39 or 0.4. We used triple glazed windows that were uncertified in this project. So in order to do that, what we had to do was some thermal bridge modeling and over insulation of the windows. This project was the walls and the roof systems were prefabricated by Collective Carpentry. And there is a great picture here of how, because it's a vaulted ceiling, how the ridge beam has been prepped for being air sealed up against the roof deck. We used the Novus Paul Novus, which is, I don't think it exists anymore, and the Comfofond, which is a perimeter glycol loop for preheating the HRV. We just used an electric tank for the domestic hot water, and this does not have a heat pump. This house does not have a heat pump. It's just electric resistant heating throughout. So the other key feature for this house was the simple design, and it's a small building. So because it's a small footprint, the volume to footprint makes it more difficult to achieve passive house. So when I was brought on, the design was mostly done, but when we ran it through the passive house planning package, we realized that we needed a little bit more solar gains, so we had to add a window on the south side. And also, in order to achieve certification, we had to do thermal bridge modeling for all of the connections. You don't always have to do that, but we were just on the edge of certification, so we had to do an awful lot of thermal bridge modeling for this project. But in the end, certification was achieved, and the owner of the building's really happy about the house and about living in the house, and his motivation for doing this was he was the mayor of Valemount at the time, and he wanted to set an example, and he hoped that everybody else in the town would build passive house. That didn't come to pass yet, but this project is a small commercial building at UNBC. It's a facilities management building, and this building was again designed by Vincent Sue, and the architect or the builder is Olofsson, and the architect was Vincent Sue. And so this is in the University of Northern British Columbia in Prince George. Again, the heating degree days, still considered a cold climate, but still not as cold as Winnipeg. And it's a two-story office building. There were some interesting parts of this, and one being the cantilever, big cantilever for doing the second floor. There was a lot of requirements by the owners at UNBC of what they needed for the building, but they were determined to have a passive house building. UNBC has set a standard for their new buildings to all be passive house certified. So we used a couple of ComfoAirs, HRVs for this project, and they are certified for cool climates. So it's a cold climate. We use cool climate components, and all that means is that we have probably got to do something else to make the building work when we're not using cold climate products. So cold climate products, there aren't a lot of them. The reason there aren't a lot of them is because there isn't a lot of ask for them. There's an awful lot of people living in climates that are cool or moderate, and people that live in cold climates aren't requiring enough products in order to make it viable to deliver really good performing products for cold climates. So we end up using cool climate products often. And in this case, we also had windows that were not certified for cold climates. So we had to do a bunch of over insulation and a lot of thermal bridge modeling in order to use those windows and prove that they worked. Again, this is a really simple shape, and what we have is a box and a great building envelope, which helps a lot with the project. We had some challenges with not only the cantilever, so you can see with the cantilever we dropped the framing underneath and filled that up with insulation, but we also had an existing retaining wall that we had to do some funky details for. But we ended up with an airtightness of 0.5, which is great. And this is an example of what we had to do with the windows. We had to over-insulate on the inside and the outside in order to achieve what they call good hygiene. And that's a German term for just saying that these windows will never have condensation on them and that you'll always feel comfortable near them. We added a little bit of shading for the windows. We installed the windows mid-wall, which is pretty typical for a passive house project. But we also added some shading elements outside of the strapping, which is a very good detail, and the shading details or the shading elements do not go through the building envelope. They're supported on the strapping on the outside. And again, we used Design PH at the beginning of this project just to be sure that we were on track before we got too far in, and that we were working on the details beforehand. And this project was certified through a certifier. The certifier that we used for the first project was a North American certifier, and this one was with a German certifier. Those certifiers work independently of PHI. They are experts in this field, and they help with help the team to understand where they should go with the project. Okay, now I have about 5 minutes left, I bet. I have PHIUS is the US version of PHI, and so they use the same principles as PHI, but what happens is that the PHIUS requirements are climate adjusted. So it's not a hard and fast 15 kilowatt hours per meter squared. It's adjusted for the climate. So for this climate, it'll be around 30 kilowatt hours per meter squared, which seems like it's a lot more, but it actually is not that much different in terms of performance. The other thing about PHIUS is it's based in the US, so it really depends on Energy Star for certification and the whole system for the DOE Energy Ready Home program, which is established in the US, which makes it a little bit more difficult in Canada for sure. So in this case, what we do is use a software called WFI, and WFI is not the spreadsheet that PHIUS is. It's a software that was developed for hygrothermal performance for buildings, and it has a portal. There's a specialized software for doing the PHIUS certification, and once you get through to a certified building, then you're able to determine whether there's going to be some moisture or dew point issues, hygrothermal issues. So we have to have Energy Star certified equipment, and that has turned into kind of a issue just because that's an American standard, and that there are not necessarily the equipment that you want to use or need to use is certified, and you'll take a hit in terms of the efficiency that the PHIUS will accept if it's not certified. It does require all of these things as well. In the radon mitigation, it does look at some other things that PHI does not look at. This is why the software is called WFI. And is anybody German here that can read that? It's a funny name. It also uses a SketchUp program for just doing the basic model. So it's got a plug-in. You can throw a SketchUp model into the software in order to have, and a Revit model too, into the software in order to determine the size and the volume and all of those things of the building. So WFI is kind of like Design PH plus PHPP. How's that for acronyms? Okay, the PHIUS certification process is a little bit different because the team that looks at the project at the PHIUS, it actually is part of PHIUS, and it's not a separate certifier. But the parts that are the same is that you have to engage a certified passive house designer, consultant at the very beginning, and the teamwork is so important. Working through the WFI model and making sure that you're on track is very important during the design process, and there's a lot of consultation and planning beforehand. This project is being built right now in Canmore. That's west of Calgary, and it's still in Zone 7A and still not quite as cold as Winnipeg. This is a project that I've designed as well as worked on the certification for. What's cool about this building, and I've only got 2 minutes, so I'm going to go real fast, but the continuous insulation and the continuous vapor control layer, and then of course we did some prefabricated walls. At UNBC, we built the walls. It was still a Larson Truss project, but we built the walls on site. In this case, they were prefabricated. We plan on over-insulating the windows, and we have exterior shading blinds in this project. But this is the most interesting part of this project, at least I think it is. We prefabricated not only the walls, but a flat roof system for the building, so that it was a complete building envelope that was installed in 3 days on site. And so this is a completely sealed building envelope. And then we have just one thermal bridge that we had to calculate for this, and that we had to do with some overhangs on the front of the building. And this is what it'll look like later. So what we did was the box and the thermal insulated box, and then we added a grate roof on top with a lot of insulation on top of that. I know I have about 30 seconds. We've heard this already, but it can't be spoken of too many times. In order to build good buildings, you have to assemble a team from the beginning, and the owner has to be on board and understand what the goals of the project are. It's really a big deal that the team works together, and that you hire a consultant, whether it's a passive house consultant, or in the case of something that might not be certified, certified energy analyst, to be sure that you're on target for what you're trying to do with your project. It's not a siloed system. An unsiloed system is the way to get a better building. In other words, everybody's working towards the same goals. And that is the end, because my time is up. I'm going to just get to the end, and just to say I am the president of Passive Buildings Canada. I also belong to an organization called Passive House Alberta, for which I'm the treasurer, and a member of Passive House Canada. And this is my logo. Thank you, guys.